Again, it's been an interesting couple weeks. I'm sure you guys have heard some new developments in the AI world, and you guys being here is just today demonstrate your commitment to innovation and your willingness to explore new possibilities. So thank you. My name is Natalie Suarez, and I'm the Director of Marketing of Allganize as an AI solution software development here in Houston, helping organizations through automating processes and capture information from unstructured and internal working documents. So today's seminar is to provide you with valuable insights and knowledge from experts in the field who will guide us through the intricacy of generative AI and its application in the oil and gas industry. So thank you and enjoy this insightful lunch and learn. And I'm going to introduce you to Changsu Lee. He's our CEO here and founder of Allganize Inc., where he developed a proprietary powerful AI solution to utilize natural language understanding to automate business workflows. He's an expert in deep learning process automation analytics. And Changsu was the CEO of Five Rocks, which was an advanced analytics platform geared for mobile developers. With a significant number of game developers adapting to Five Rock platforms, the company was successfully acquired by Tapjoy in 2014, and during his tenure at Tapjoy, Changsu held an executive position as Senior Vice President of Platforms, where he managed the analytics platform for mobile apps. Changsu holds a master's degree in computer science, specializing in natural language processing at Korea Advanced Institute of Science and Technology. In his free time, Changsu enjoys learning new languages as a hobby, resulting in his ability to speak 5 different languages. Our second guest is Reishin Toolsi. He is a solution architect and energy subject matter expert at Databricks, bringing together both his passion for AI and the connected energy ecosystem. He's leading the efforts to better understand their clients' needs in this space. Prior to joining Databricks, he spent 14 years at Schlumberger, where he led multidisciplinary team across the global portfolio. Reishin considers himself to be a global citizen who was born in South Africa and was fortunate to work all over Europe, Asia, Africa, the Middle East, and North and South America. He feels his global perspective is both humbling and allows him to better connect with clients and coworkers alike. His previous experience ranged from software engineering, game development, and developing medical diagnostic devices, including having led collaboratively engagements with NASA on the Mars mission. He is also a speaker, panelist, and podcaster for both the energy and space technology industry. And last but not least is our Gabriel Perez. He has a strong background in drilling operations and project management with international experience across multiple continents, including Africa, Europe, and the Americas. He has worked with reputable companies such as Geostock, Shell, Gabriel, Enron, Marathon Oil, and Oxy, and his experience spans the entire energy sector, including upstream, downstream, and renewables. He holds a degree from esteemed institutions from Norway, the UK, the US, France, and Venezuela, which have equipped him with a diverse and comprehensive understanding of global energy practice and industry dynamics. That diverse experience enable him to tackle challenges from multiple angles. And without that, we are going to go start with Changsu Lee. So thank you and enjoy this insightful lunch and learning seminar. Changsu?
Thank you, everyone. My name is Changsu Lee. I'm founder and CEO at Allganize. Today, I'm going to talk about generative AI and how to utilize generative AI in your process innovation. So I studied computer science from 1997, and I was doing natural language processing and AI side about more than 20 years. So AI history is actually quite long, but from the last year, November, ChatGPT came out, and it actually changes really many things. Now people are really realizing, okay, this is something that actually going to change all of our process in the company and in our daily life. So for me, the first the wow moment was actually 2016's AlphaGo. So because in computer science we've been always talking about in a world of chess, AI can beat the human pretty easily. So that happened a long time ago. But in a world of Go, because there is so many possibilities, so many the passes. So the computation cannot really beat the human. But at 2016, and then Google they released the AlphaGo, which was trained by reinforcement learning, and actually the beat human Go champion Lee Sedol was 2016. So if you're not really familiar with reinforcement learning is all about like the designing the reward system, and so that AI can actually try all the cases as many as possible. Then once this AI gets reward, and it actually reinforces in that behavior. There are three main way of AI. The first one is reinforcement learning. The second one is supervised learning. So supervised learning is human gives the correct set label and to the machine, and machine is trying to mimic that label. That is supervised learning. And the unsupervised learning is human doesn't give any label, and the machine tries to understand like the intrinsic pattern of the data. So there are like the three main ways. And raise your hand if you guys have any of this AI speaker. Yeah, most of them, right? And have you ever realized when you communicate with this AI speaker, you cannot really, freely talk to this AI machine, and you actually filter yourself out, right? Because you're not really sure how much this machine can understand, right? So this is also AI-equipped speaker, but when you are not really sure how capable of this AI is, you cannot really give the task and to this, the AI machine. So that is like kind of, it's called kind of the uncanny valley, and then also like intrinsic interactions, and when you are communicating with not really smart enough the machines. But if you see here, like the GPT-4, and then you see, like you probably read many articles, GPT, already in the past, the bar exam in SAT, GPT already passed, and it surpassed like the average human scores. So this is already happening. So we were talking about some what limited the AI capability, and then humans are actually tends to filter themselves out. But when we are communicating or interacting with smart enough in AI, people actually gives everything into the machine. So if you recall the movie the Her, right, and communicating with those voice assistant, actually understand all these situations, environment around you, and it can actually get advice and then directions via AI. So that is actually the happening. So this is like the beginning of the new era, and this is really exciting. And then why ChatGPT, only ChatGPT is making this the big sensation? Is this the only large language model? The answer is actually no. Like if you see here, there are tons of large language models, and then actually GPT is not the the biggest model, right? Then why? Why only ChatGPT is making this big sensation, and what is the secret sauce of the ChatGPT? And then we need to understand this. So GPT-3 was actually released at 2020 May, so it was a long time ago. It was not last year. And this one, Instruct GPT, is called like GPT 3.5. This is the key. This is the key. And if you see here, RLHF, so I'm going to tell you a little bit more detail about the RLHF. This is the secret sauce like that makes ChatGPT such a smart ones. And ChatGPT is just one layer up on top of GPT 3.5, like safety. Here, safety is like AI. You cannot really tell like some of the sexual the stuff. You cannot really tell about some political issues, sensitive issues. That's all. So here the key is this one, RLHF. Then what is RLHF? This GPT model is basically trained by unsupervised learning. So GPT model is basically trained only to predict next token, next word. So just giving tons of big text chunk. It's called like corpus, like all these web data, all these text data. Just put it into the machine, and then this AI is only trained to predict. Okay, what is going to be the next word, next token, right? Pretty simple and easy, right? So that is unsupervised learning, and on top of the unsupervised learning, and then this team, OpenAI team, make the supervised set. The supervised set is, okay, if we give this kind of text, then you should respond this level of text. Okay, so the prompt and text that we pass to the AI, then, okay, this is the proper response, and for this given text. So just two text pairs. So making the label data set, and then doing it as a supervised learning. And then here running the reinforcement learning. The reinforcement learning is, because this is generative model, it can generate many different responses, and for the text that we are passing to the model, then here Here, human labeler also gives a priority. Ah, okay, this response is hilarious. This is the best one. This is like second, this is third, and this is fourth, like something like this. Then with this priority, if the model predicts here the top priority answers, then it got reward. So here's the point. So I told you like there are three main ways of the learning: supervised learning, unsupervised learning, and the reinforcement learning. So actually, GPT 3.5, Instruct GPT, is kind of the first model which is utilizing all of these three learning methods. Started from the unsupervised learning, then learning it to the supervised fine-tuning, then doing it over and over again by the reinforcement learning. And then it makes model such a smart one. So that is kind of the first one in the world, and then it shows us amazing the performance. Then what is yeah.
What does that acronym mean? The acronym. You went 2
Oh.
slides ago, and there was an acronym.
Where?
One slide before this. RLHF.
Is reinforcement learning with human feedback.
Okay.
Yes. Thank you. Then, what is the difference between the generative AI and like the traditional deep learning AI? It's quite awkward when I put like traditional deep learning, because deep learning itself is like less than 10 years in the history, so that is pretty awkward. But traditional deep learning model is we prepare, like let's say you want to build some kind of sentiment analysis model, okay, by using a traditional deep learning model. Then first of all, you need to train or fine-tune the model. So most likely there is like a pre-trained model. Then you need to do the fine-tune and with this kind of training data. So let's say I love this pizza. This is like positive one, right? Then you put 1, and then this is a correct combination. Then you give the label 1. And then if you put like, oh, okay, I hate this place. This is negative. Then you put 0. This is also in the correct combination. Then you put label 1. Okay, this pizza is so good. This should be positive, right? But you also need to give like negative data. So you put 0 here. Then this is incorrect combination. Then that's why you need to put label 0. So this is how you collect data and how you fine-tune the model. Then when you actually use this sentiment analysis model, so this is how it's working as an inference. So you put the sentence here, this place is awesome. Then, because this is sentiment classification, so the only possible answer is positive or negative, right? Then we need to put all these two things into the model and then check which has higher score. Score is usually come like 0 to 1. Then the first one got the higher score. Then this model predicts, oh, okay, this is positive. This is how traditional deep learning model is working. But with generative AI, because this model is being trained to generate the next best token word and sentence, so this text chunk that we are passing to generative AI model is called prompt. And then here is like kind of the best practice in how to write the prompt. The first, you need to give a detailed instruction. Okay, analyze the sentiment of the customer reviews. Then you probably give the example. You don't really need to do it always, but if you pass this kind of just 1 or 2 example, like detailed example, it actually works a lot better. So the first example here, review, I love this pizza, sentiment positive. The review, I hate this place, and sentiment negative. Then you actually give the sentence that you want to analyze. This place is awesome. Then you can see here like the green, and then in sentiment column, this is the end of the text that I'm passing to generative AI. Then generative AI just completes the next one, positive. So the biggest difference, the biggest implicational difference between traditional deep learning model and generative AI is generative AI model is task agnostic, right? So here, I just told them, please do sentiment analysis. But you can use just one model and 100 different tasks. You don't really need to have all different models. But if you take a look at a traditional deep learning model, every single task or every single 1 or 2 tasks in a set, you need to have a different model. So in order to have the different AI model, and you need to have like different model deployment process. So it actually takes a lot longer time and then to apply this AI model into your process. So that is the biggest difference. Just having one really big smart model which can be applied all the different the process and then different tasks. So that is the biggest differentiation of the deep learning and generative AI. So this is me in carbon tracking and reporting in a conference as a panel like 2 months ago. Like just as I briefly shared the background, I was studying computer science and AI. I've been working in data and AI side in the last 20 years. So I can speak about data and AI all day long, but I'm not the petroleum engineer. I'm not the environment engineer. So those detailed topics of the carbon tracking reporting, I cannot really do the panel this smoothly. So the many cases and how I was learning something new in a new domain was actually getting into the Wikipedia page and just listing up and saw all like the basic and beginner or for dummies in the pages and to understand some basic concept and then do the navigation of this new knowledge by myself. But it takes a quite long time. This time when I was there, it was like 2-day conference and I was joining as a panel on the second day. So the first day, I was sitting there and then listening to what speaker and then panels are talking, and if there is any new concept that I don't understand, I just ask it to the ChatGPT, and then it actually gives very very well good explanations, and it was also telling me what should I take a look at next. So when I comparing myself, like who was navigating new knowledge and then just by myself and going to the Wikipedia and then clicked into the next pages and comparing myself and then having big smart large language model ChatGPT as my knowledge assistant, and then I was comparing how effective and how efficient I became to utilize this large language model as my knowledge assistant. So after having this in a personal experience, I actually swapped these two positions in my cell phone. Chrome was actually here. And GPT app was actually in somewhere else, but I changed it to the locations. I don't think I can go back to my previous the self, and because it was just so inefficient. And then thankfully this is not only me. I'm going to share pretty interesting statistics and all our customers data. So through this experience, I was really realizing this quote is just so true. AI is not going to replace any human, but if there is a human who is utilizing AI really well, and then this human is going to replace. So in order to explain our interesting customer in the statistics, and then we need to explain what we are doing. So we are focusing on this issue, especially in the oil and gas domain. If you think about like talent influx and talent outflux, and knowledge management is extremely important topic in oil and gas domain, and your employees are actually spending a lot of time sitting there, and when they're communicating with like those in the field engineers and then many different the changing the guidelines. So our solution is, and because most of the companies, especially oil and gas companies, in the internal like the search system, the employee portal is not really. It's not like the Google type of search, right? So just people and put the keywords, find a document, and opening a document, do the Control F, and then to understand what is going to be an answer for the question. So that is the typical process. And we were providing the cognitive search solutions. So any kind of the unstructured data, PDF and Word and PowerPoint, just asking a question, then AI is giving an answer. So that is our the main the product. So we've been providing this service and then to more than 300 enterprise customers in US, Japan, and South Korea. So we have tons of the user behavior data. And one sad news is, even though our customer understand that, if they ask a question, who, when, why, kind of question, when this regulation has changed, like which year, like which department is responsible for these exceptions, these kind of questions, AI just need giving an answer, so they don't really need to put the keyword. But when we see the existing customer statistics, and when we analyze the query, and we were seeing like 59% was still keyword-based query. So we were thinking, okay, it's just so hard to replace or change the customer's behavior. That was our internal conclusion. But at the beginning of this year, so this cognitive search model is kind of the combination of the different AI models, and we have replaced the last the model which finds an answer into the LLM models, and we have launched this product at the beginning of this year, the February. And we have acquired around 10 plus enterprise customers, and we have seen the data. And amazingly, this LEGPT customer here, 71% is sentence-style queries, and only 29% is keyword-based queries. So our conclusion, our internal conclusion, okay, user behavior is just so sticky and we cannot change it, was not correct. Just technology wasn't that good enough, and to give a strong confidence to the user, okay, you can ask whatever you want to ask, right? So when the AI is smart enough and it can actually change the user behavior, so it was not just me. And but then, the most infrequent question that we are getting in from existing customer and a new customer is, okay, we want to utilize like ChatGPT, level LLM into our process, but how we can use it, right? And the first the obstacle that business customers are actually seeing is these GPT model, LLM model, don't really understand our internal data, right? So for example, here, this is also about net zero, like Inflation Reduction Act is pretty hot potato and for the oil and gas industry. So if you guys are asking question about this one, then this is GPT-4, not GPT 3.5. It doesn't give an answer. But if you ask a question to our LLM, which is also utilizing like the ChatGPT or in the Google Palm or your choice of the LLM, it can actually give the correct answer with the highlight into your internal document. So to bring ChatGPT level quality LLM into your the internal knowledge base is what we are doing. This is something that we have started this year. What you need to do is just upload these documents as, or just connect to your internal document repository. Okay, then still public recognition of ChatGPT LLM is still through the conversation. And this is amazing, still very amazing. You can use this for helping your kids in homework, or if you want to learn something new, and then you can ask question here. But the LLM application is kind of a completely different concept. The building a new application based on the LLM, and then this one can communicate to any of your the systems, like the reservoir management or net zero carbon tracking and whatever type of the systems the LLM can be utilized there. So for example, here you ask a question, list of all the activities for tax credit monetization for Inflation Reduction Act. So you need to do something, and then for this Inflation Reduction Act, so you can, first of all, the list of all these, the action items or activities, and then this can be, embedded. So let's say, okay, you got a pretty good list, and then from the LLM, and for these suggested activities, and if you can compare, these AI suggested activities and to your current activities, you can actually set up, okay, what is going to be your 30-day, 6-day, 90 days action plan, right? So this is something, the whole human-only, capable, the kind of the actions and plans. But this kind of thing actually can be automated when you do the training of each, LLM prompt. So the embedding means, okay, you send some request into LLM, you got the response, and you can reutilize this response into the second action item. And these days, if you ever heard of the AutoGPT, and this LLM actually can plan what would be the next action item that they should ask against themselves. Still in pretty nascent in the research area, but it shows a great possibility. This kind of like action item planning, design and execution in this level of the work, LLM can be utilized. So in order to utilize LLM in your real process, everyday process, and there are a bunch of things that you need to take care of. The first thing is, of course, in security. So you guys have probably ever heard of what happened to Samsung Electronics. Like one of the engineers put their the code into the OpenAI. So which kind of data can be passed into LLM, or which kind of data cannot be passed, or the very conservative the customers or the industry, they are actually asking about, okay, we want to have the on-premise LLM. We don't want to send any kind of data to OpenAI or Google. So that is also possible. And LLM is going to come out like this year, next year, new LLM is going to come out, and then whenever you guys are replacing this baseline LLM model, and if you need to do all the the application area, do the re-engineering, and that is going to be the waste of time. So it needs to be the abstract enough so that you guys always can replace your baseline LLM, but still maintain all of the top engineering side. So that is the concept of the LLM, the application and LLM infrastructure. And then I think this year, and if you see how quickly this area is changing, and this is the real beginning year of the LLM and LLM application. So I think this is something like the internet in 1995.
Americans own a personal computer. If you're one of them, you can now glimpse the future with nothing more than a modem, a phone line, and a few dollars a month. And the mark with the A and then the ring around it. See, that's what I said. Katie said she thought it was about. Yeah. Oh. But I've never heard it. I've never heard it said. I know I said the mark, but never heard it said. And then it sounded stupid when I said it. Violence at NBC.
Just what is this main artery of the information superhighway?
Every business, no matter how large, no matter how small, will be on the internet in the year 2000. It's the primary way that people will look up information. It will replace the yellow pages as we know it today.
Are a lot of people just getting onto the internet because they feel that they have to get onto the playing field, so to speak?
But it's very hip to be on the internet right now. There it is, violence at NBC, GE.com. I mean,
Well, Allison should know.
what
What do you
is
say that,
internet
Allison?
anyway?
Internet is that massive computer network, the one that's becoming really big now.
This is a very hilarious video, but I think AI or the LLM 2023 is exactly the same with internet in 1995. I don't really want to prove like my age, but I started computer science in university in 1997, and then I was like started writing a computer program like 1992 or three, something. So I was actually seeing how people were responding into this, the internet, and then all these like the IRC, started chatting and etc. And then now we see we cannot really, live one day, without internet, right? And then I really believe AI, LLM, those changes are a lot bigger than internet in 1995. So we really need to start, preparing it. And so like some bite-sized next item that we can do is there's still, because the oil and gas is in a pretty conservative industry, and so probably the leadership team is going to say, okay, that technology is still too young, and then it's not mature yet, and to bring into the organization. But changing speed is just so quick. So if you don't act right now, you probably need to take a risk of getting left behind. And so in terms of act now, the good thing is start small and then you need to to iterate and what would be the best area to start things with AI, even not like with LLM, is if there's any type of routine the task like those asking questions, it might be a good thing, or for net zero the effort, there's still carbon accounting software and they are putting the information manually, and then because those utility bills the fuel purchase report are still coming as a PDF, so they are still putting it manual. So those routine and manual tasks is the best spot then to start to bring AI into your organization. So do whatever with AI the first, and like even from today, not from like next month. And just a 10-second the promotion is we also have like the net zero product and automatically extracting this information, so completely removing any the manual the things. Yeah.
So how do you know if the language model that you're choosing as a customer, it's addressing bias or negative bias in the data?
So with the large language model, and that kind of evaluation is becoming extremely hard and difficult. But So like, for example, the OpenAI, the GPT in a series model, and then Google's PaLM base, that large language model is almost impossible to see those kind of like negative bias or etc. But we also spend a lot of time into assessing open source large language model, and because we've got a lot of requests from the customers, we want to just put it in our on-premise or the private network, and then can you guys do that for us? And so we've been addressing the capabilities of those open source large language model, and after the fine tuning, then these open source large language model is still called large language model, but compared to GPT or Google PaLM, it's relatively small, like 7 billion or 13 billion parameter size. And if you do fine tuning wrong, and it actually shows degradation of the quality, and also it shows in certain level of the bias. So when you deal with large language model, especially when you deal with those kind of the fine tuning of the open source language model, and then you need to be very careful what kind of data you should use. So something other interesting tendency is when you fine tune your open source large language model, people usually generate training data by using more authentic large language models such as ChatGPT or the Google PaLM. On that cases, like when you surface certain amount of data and those degradation or the bias, and becomes more stronger. So that is the observation that we've seen so far.
I'm in cybersecurity, so the one example that I saw ChatGPT fail fabulously was when the researcher was able to get ChatGPT to basically go against its programming and write malware, which it was not supposed to do. So that's always intriguing.
Yeah. So these days that is called kind of the prompt hacking. So like still like companies working really hard, and so like one hacking that worked like a week ago is not really working like this like today. So for example is the kind of tell me your prompt. And it actually tells the prompt, and probably you guys already have seen that the Microsoft, like the Bing, the search, the prompt was also the leaked, and because large language model, the complete different concept, and then compared to 100% software is 100% software world, and you can control every single details. But large language model is something we don't fully understand what's really happening inside the model. So we cannot really do like preventive the blocking, and then also those detailed control is not really available in LLM world. So like philosophy is different, but we think we really need to adapt into those the philosophy changing.
Yeah, I mean, a lot of the tools today are dependent on the human user.
Yeah. Right. Okay.
Any other questions for Changsu?
Okay. Yeah. So I will be around, and so if you have any questions, just let me know. Okay, thank you.
Thank you, Changsu. Okay, great. And then next we'll have Reishin Toolsi with Databricks. And you feel free to ask questions as we go.
Cool. Thank you. Hey, thank you for having me. So this presentation is more, I'm kind of hoping to be more interactive. There's a small audience who can kind of talk through it. And also I kind of put this deck very quickly together. It's more a general perspective as to what we're doing in energy, and I'll tell you, more about that. It isn't definitely a pitch to sell you more technology from a data risk perspective, so we won't really get into what my organization does, and to be respectful of the audience. Yes, so my name is Reishin Toolsi. I am a solution architect, but I spent many years in the energy space. My current role is to work with you guys. I work with multiple energy companies, both oil and gas, renewables, and also now the utility company as well. Right? So I kind of put together a finding of what we're seeing, and I hope it resonates. And see, so Changsu kind of gave a very technical perspective. Mine is maybe a little more philosophical. So we'll see, which one resonates more. Although I did enjoy his talk more. So I love this quote. Those quotes given earlier. I love quotes because it's kind of a nice one. This one is actually a quote from a Swedish inventor of a battery. Is this working? Yeah, there we go. higher. And really, this is where we're kind of seeing it, where energy is actually is more propagating towards, is that energy is connected, it is personal, it impacts all of us. I spent many years, obviously, in the industry, and I'm still connected to it in a personal way, but also I consume energy. I assume everyone in this room lived in a house or uses a house or uses a car. At some point in your life, you've done these things. You consume energy in some capacity, hence you are consumers of it. But actually, what we're also seeing is that the energy world is changing right now. So there's two large factors that are impacting the energy world. One is that the type of energy will change, moving away from hydrocarbons and moving towards, traditionally more green type energies. But, hydrocarbons will always be around as part of in my entire lifetime. So, and I hope to live for a very, very long time, so that'll still be around very long. But the other thing that's changing is that we are seeing this rise in digitization, right? So the cost of technology, are there anyone from the cloud hyperscalers here in the room, IoT vendors in the room, the Amazons?
We have a cloud product.
Yep, there we go, right, yeah. So the cost is going down, right? So, so that's a good thing because you can scale on that. The cost for IoT sensors is going down, right? And then that means many things, is that it's exciting, we can do more things in the clouds that we were once afraid to do because of cost and because of market penetration and scalability. But also for every heavy asset we have out there, we will now start sticking IoT sensors on them, and we want data from them. And not that we want data, we also want data in a fast and highly available way, right? So look at our personal and professional lives are now connected. There you go, higher. I don't think this thing works very well, but all right, that's fine. Our personal and professional lives are now kind of connected in a certain way, right? So 2 or 3 years ago, if you have Netflix or Amazon Prime, I'm not pitching any products, but you would have been quite happy at 720K streaming. Now you lose your mind if it's not at 4K resonating every single second at a time, right? Your personal devices, your phones out there can now basically visualize and show information at such a high penetrating rate. You can do so much more with those devices because you're connected to an IoT device that's highly functional, but its infrastructure is in the cloud somewhere, so you can do many things. Recently, we bought a house 2 years ago, and I did everything on my phone, right, which is unheard of. Right? So the demands in our personal life have changed, so the demands in our professional life changed. So even though the world has gotten better for cloud and technology, we still want it. We want more IoT sensors. We want more data. We want fast data. But that kind of adds some challenges to it. And even though we are talking about AI, the core for AI, and we know this, right? Good data in, good answers out, bad data in, bad. We know this, right? But what I'm trying to get to is that we need to start thinking about this in terms of ecosystems, ecosystem of challenges. So if you take this example where you kind of have these 3 disconnected sets of ecosystem, right? So, a hydrocarbon-based energy, one has to do with whether or not retail industry exists, and then one is we want to start looking towards a sustainable future, which is usually construction. So you have, oil and gas, you have renewables, and then you also have, the construction industry based on that, right? Each of these have their demands. You may consider them to be independent, but actually they're not. They have vendors, traders, ISVs. These data points are all connected. If you think of it and just kind of draw a kind of an invisible horizontal line between each of these ecosystems, they fundamentally become connected. So solving challenges in one of them demands working with the other, right? And the way we see it is that, if we kind of had this connected ecosystem with an open source data ecosystem at the bottom, kind of funneling it together. Now, many of you probably work in some of these entities, maybe not all of them, right? But essentially, there's very few that actually have the entire value chain of this, right? You could work in generation, you could work in retail, you could work in 1 or 2 other factors of these components, right? But in order for you to kind of solve these problems, before we even get into learning models, is you do need a connected ecosystem that can manage these kind of data points together. And this is what we're seeing in industry. It's what we see with our clients. If I even take my product offline, just take the cloud majors in only, without a kind of open source data ecosystem that allows you to work with open source data, allows you to work with a vendor neutral data format that's usually open source or Parquet, the challenges become more complex to kind of solve. You have any questions on this before I continue? None? All right, that's a pretty good job then. Changsu did a way better job than I'm going to do with this. I'm not a large language model or a data scientist. I work more in data engineering, and my background is in traditional oil and gas. But actually, what we kind of want to talk about is actually the use cases that we are seeing penetrate amongst our oil and gas customers. So, who's in traditional upstream here, oil and gas? Like, what's your backgrounds? All. What do you guys do?
I work in IT for upstream.
Okay, yeah. No, you don't have to give me the client names and all.
Oh, Ring and, yeah.
Oh, Ring Entry. Okay, yourself?
We provide quality assurance and engineering services to upstream operators.
Okay, great. And did anyone else put their hands up, or no one?
We have a software product that we sell to upstream.
Okay, yeah. So similar sort of world, right? Yeah. So we are seeing that these are the traditional use cases that we are seeing kind of like penetrate, right? And it really has to do around kind of like content generation, content creation, and sort of like think about like the oil and gas industry has billions of data points that's basically sitting in documentation right now. That's sitting on rigs, that's sitting on plants, that's sitting in documents right now. It's sitting in conversations that's disconnected, just as the example we had about this kind of like disconnected ecosystem, right? And the best way we are seeing for chatbot to actually, make it be advantageous around it is to basically extract that information, use an open source connected ecosystem, extract the information, make it scalable, allow you to basically remove the silos around them, so you basically have this connected ecosystem of data, and then start actually producing value on them, right? Are you all seeing large learning models kind of like, penetrate into the market? What do I have next? Oh, yeah, that's the bad one, yeah. Are you guys seeing this in your industry with your clients? Are these LLMs taking off, or are they just chatbots in your personal life?
Any customers ask for it?
That's a good point, yes. Okay, so let's start with that. Yourself, anyone else? So right now, OpenAI and ChatGPT is by far the most prominent one, but it's certainly not the largest learning model. And now that Microsoft has made an investment in that, we are seeing that the customers that use Microsoft have been asking about OpenAI. I can't go one day without any customer asking me about, tell me about LLMs and tell me about OpenAI and tell me about ChatGPT. And what we find is that with most of these organizations, they can't use ChatGPT within their infrastructure. Because the reason is data has to leave the infrastructure and basically be processed and trained outside. And we see some issues, and we're going to discuss that in a second, right? So we are seeing the rise of LLMs. We're seeing the need for it, but the question is, what can we do with it? We'll kind of talk about that in a second, right? I like quotes, right? So this is kind of a pretty cool one, right? So, we love technology. I'm a technologist. I love, as much technology, but it can be dangerous, right? And a kind of good example of that is, do you guys know what happened with Samsung? And this is not beating up Samsung, an excellent company. And this, do you guys know the history of this? What happened? What's our cybersecurity expert in the room? It's essentially the engineers were trying to train data, and they basically let the data leave the system, and they had confidential information that became part of the open training model, right? So they revealed some confidential, which is, most of us that work in corporations realize that's a fireable offense. I hope they won't fire it. I hope it's a learning experience for everyone, because this is brand new, right? Large learning models, we only found, let's be honest. I mean, unless you were deep into NLP, you never heard the term LLM until a few months ago. And then suddenly it's all everyone talks about. I'm in the data and AI space, and I had no idea what an LLM was until a few months ago, and we realized, oh, we have our own product. And I won't talk about that, but because I'll be pitching, right? So the question is, like there's other issues with ChatGPT. And it's that it also hallucinates. So it's not just ChatGPT, but AI hallucinates. I mean, we have enough problem with humans hallucinating. Now we have AI that we have to deal with in the human world, right? Again, all these things exist in the human world. I have no issues with AI taking over the world. I say, have at it. We haven't done a great job ourselves. We'll give you 5 years, and then we'll think about whether we'll get rid of you or not, right? But the issue is now that it hallucinates. We are seeing real consequences of it. There was a case that went to trial where lawyers are basically using ChatGPT. And they basically started quoting things that didn't exist, right? And then this is something to think about, because there was a question about bias that came up. We'll get into that in a second. The problem is, we need to trust but verify, right? Go back to old school way of thinking about, AI produces data, but it doesn't give us an answer. All AI does, and all generative AI did, and you can challenge me on this, is a probabilistic answer. That's all it is, right? How we basically want to interpret that and actually use that as a guide or thing. But if you ever have a doctor, and I've said this before, and I get in trouble for saying this, if you ever have a doctor that uses ChatGPT for diagnosis, find another doctor. That's as simple as that, right? Fire your lawyer, right? Because like that's just insane that we're using it. So why would we use this in our professional world without trust but verify? It is a guide to help us. That's all it is. Yes, sir.
This is the same reason why would you get behind the wheel of a vehicle that can, quote, drive itself and trust it to do so?
That's it. So I have one of those vehicles, which I do not trust to drive itself, but I use it to help me. So I will never take, because I have precious cargo. I have kids in my car. I will never allow the vehicle to hands off and then basically, I can catch a 5-minute, snooze, power nap on, on the I-10. That'll be insane. But every now and again, I have noticed that actually when the weather is kind of bad, Houston weather can be terrible when it rains. When it's kind of dark and I can't see very well, the AI is a second pair of eyes that assists me. So that's all it is. It's here to assist us, right? So trust but verify.
I think that's the big key, is that a lot of people think because this is new and coming out that it's proven. It is not.
It'll never be proven, right? The internet is a great example. We saw that in 1995 and internet. Everyone, I'm hard pressed to find someone who doesn't use the internet. There's always someone out there that says, I've never used the internet. Right? It's like, well then, how did you find out about the internet if you didn't know about it? Right? So he clearly Googled it. Right? So the question is, like, it is trust but verify. We still don't trust what's on the internet. It's getting worse and worse right now. So it does involve us kind of making some societal changes. Right? So the question is, can these open systems help us tackle some of these problems, right? And the reason is, and this is what the big bets are, is how do we deal with bias? And bias is subjective, right? And so is a factual answer, because AI will not give you a factual answer. It's not a binary response. It'll give you a probabilistic response to something. And the probabilistic response means that there's a variable of whether it's right or wrong. It's probably more right than wrong, but it depends on the training set. And what we find is that with closed models where data is off somewhere and has to be trained and can't be inspected, it's harder for you to manage liability. With open source and open set models that are trained, if you ever encounter bias, my answer is, well, then look at how it was trained and then basically train it better. Right? So ChatGPT, we're beating up on ChatGPT here, but has been proven to be biased towards one style of thinking, one political alignment, whatever you want to call it. Right? And the answer is, yeah, because it was trained that way, because the majority of people that helped train it were thinking in that direction. And if you don't like that, you can add to that model if it's open to make it more in the center. That's all it is. That's what it comes down to, is how do we manage bias and how do we kind of manage these things? Well, we're going to have to add to it. But from an oil and gas perspective, like if we start eliminating bias, so we can say, well, if it's an open model, we can open for interrogation. We can show where the biasness is not, or maybe it is actually the right answer. But from a positive point of view, imagine an environment. What if I've got them in here? I forget if I've added stuff in there. Oh, yeah. Oops. This just broke on me. Give me a second. Uh-oh. It's good. I think I'm almost there. Slideshow.
There you go.
That was ChatGPT. It figured out, but I was kind of messing with it, so it basically decided to crash my presentation. It's happening, right? They'll come after us, right? So the question is like from an oil and gas perspective, like what does it matter, right? Can we use this example, which is let's take this as a wind turbine, and this is something we proposed to a large super major a while back, right? So the question is like, you've got this large wind turbine, and fundamentally you want to start here. You want to basically have this conversation and say, tell me how turbine 15 is doing today. If you're an operations manager and you have a field out there and you have 500 wells, that's associated to yourself, right? Each of these wells have multiple assets, pumps, regulators, they have drilling equipment, they have crews around there, but it's too much information for a daily report. You probably only want to care about like what is the most things that could go wrong, any red flags. So you want to say, well, tell me how this field is doing, because you're a human being in a human world, and you don't talk to it the same way you talk to your Google or your Alexa Prime, right? You can't talk to it that way. You want to have real conversation, like, hey, what is going on today? Tell me about the day. And what you want in response is, you want a combination of different things. You want a combination of things that says, how do I basically bring in operational performance, which is factual information, and that's going to come from your open ecosystem, and that won't be part of your large learning model. But the learning model will interpret the information and basically give it to you in a more human-like way. Right? It can also filter out things that don't make sense. At the same time, you probably have things like historical information about how things were done, maintenance scheduling, information from an SME that was on the rig at the plant site, at the turbine site that's actually looking at it. You could have functional reports from the equipment itself, so you can do things like predictive maintenance, you can do things like condition-based maintenance. All of that should be engaged in some way, ingested in some way, and a large learning model should be able to process that information daily and produce a report. So you can just come out and say, tell me what's pump, what turbine, what well may need maintenance today, and should be able to pull that information, give you a report, and then your job as an operations manager, as a VP of operations or an engineer, is not to take that report and say this is the answer, is then to basically use that as a guide to where you want to go. So that's why I'm going to pause and kind of like stop it right here. Does this make sense or help you understand is that you do need an open source data ecosystem. LLMs in the energy industry will not tell us where things are broken, but guide us and prepare us and help us ingest language and help us ingest knowledge. The other problem is that the industry is getting older. This is a reality. This isn't a statement on ages. I'm on the other side of 40. I wish I wasn't. I wish I was younger. I mean, that's just how it is. I didn't know that until I got older. But the reality is, so is the industry. It's getting older, and there's lots of knowledge in that, and that's where I'm getting at, right? So there are people out there that understand the nature of the beast. They are leaving. They're moving out. They're winning the Powerball. They're getting those fishing boats and enjoying life as they should. The question is, how do you get that knowledge, that tribal knowledge, so that a newer, younger generation which don't understand it as well can absorb it? This is where LLMs can come in, right? Start reading their emails, their reports, their behavior, track that, build models, and actually help train you. That's where we're seeing these kind of advantages, right? It won't be a silver bullet to solve problems like it's being advertised. We see it more as an assistant in terms of training and actually helping us to kind of like decimate the information. So I'm going to stop here. Okay. Any questions? Yes, sir.
So if in the case where your data is proprietary,
Correct, as it should be.
how do you go about building that model internally?
And I should have brought, that's an excellent question, right? Did everyone get that question? Proprietary data, what do you do with that? Your data is your data, and most oil and gas companies have proprietary data. Data can never, under any condition, leave that. I never should it leave that environment, right? It can be whether it's processed on-prem or in the cloud, or a hybrid cloud. It should be within that context, right? This is where these open models are, right? So what we're seeing is that closed models that encourage you to leave that system and be processed are subject to risk. You can train models in your environment, and you should train them with your data. Right? You can bring in some external information. Like, I'm not pitching our own product, but there's other ones out there, like Hugging Face is kind of an interesting open source learning model. We've contributed to that. You could build an open source model in your environment with your own tribal knowledge, with your own proprietary data. It should never have to leave your environment. So that's where we're seeing these kind of open source models becoming more encouraging.
Following with that,
Yes.
So to me, the advantage of the open source model is that you don't have to have resources to operate that.
Yes.
So if I'm going to operate that internally, that model internally, isn't that going to require additional resources to be able to do that?
You could start moving towards, you will need some initial investment in training the model, setting it up, but you want to move towards more unsupervised learning as part of that and automating it, right? The advantages I should have brought this up, was that the oil and gas industry information is not open, it's not public or global. For example, acronyms, right? So most people who've worked in the industry know that there's millions of acronyms that's also subjective to the specific company. So I worked at Schlumberger, right? The way we speak about the industry is similar to its our main competition, which is Halliburton. But it isn't exactly the same. That we have a million acronyms that's specific to us. All that should be ingested into a large learning model internally, which will help us, right? But we need to basically automate that with some unstructured training, unsupervised learning to help you with that. Any other questions? Okay, I'm going to leave it here. Thank you.
And I know we have one more guest. So Gabriel Perez, like I mentioned, he is a senior project manager, well-versed of our engineers. He'll be sharing a use case today, and we'll be then opening to do some Q&A if you guys have additional information, questions.
Thanks very much. Yeah, so my speech is going to be a lot different. I'm going to talk more about my wish list and what I would like to see while doing a field development, planning a well, how I integrate scope, budget, schedule, lessons learned, risk management, and so on. The niche that I'm going to elaborate on is underground storage, which is not necessarily the same as drilling an oil and gas well, but it's still drilling. But you do it for different purposes. You do it for CO2 abatement, you do it for hydrogen, you do it for LPG storage, okay? So let's see. So if I had a wish list, the key word here would be integration, okay? So what we're doing right now is injection of waste or CO2 or hydrogen into the reservoir that needs a seal and also needs porous space and permeability, you know, the right quality reservoir, okay? We do that for storage, but there's another driver which is a regulatory driver. No? Normally, here in Texas, you have the Railroad Commission for drilling oil and gas wells. In this case, the regulatory bodies are different. Are the DNRs, the Natural Resources bodies, it's the EPA, it's actually the local governments as well. So project management is a key word, innovation, and business intelligence, because you always need to benchmark. I thought that when I started learning Microsoft Access like 20 years ago, that was innovation, you know, and I would show what I would do with real-time data from drilling a well and put it in Access and show dashboards. That was impressive. Then I thought, when I started using Spotfire, that was kind of innovative. Then I started using Power BI because, well, I don't know, for some reason, and I still show those dashboards and they look kind of innovative. But if I don't learn how to use my ChatGPT, I'm gonna grow old, that's for sure, okay? Sorry, man, that's why. How do you put it, Vic? Well, I'll elaborate anyways. So we start from the big drivers, okay? And then we go a bit more granular, okay? So a big driver is always safety, otherwise you're not even eligible for a contract. You have the community, which is also a big driver, especially abroad. Sustainability, they're treating the carbon footprint at the same level as safety. And then you go to the execution, okay? But if I had a database with all my best practices, all my lessons learned, and all of my risk registered in a place before I plan a well, my feasibility would be a lot faster, okay? Feasibility for a project can take years, but if I have a database that is organized in such a way that in natural language I can just make questions, that should for sure would be, you know, it would be a win. When you do, for example, for CO2 wells, you do something that's called a Class 6 permit. That is a new type of permit where people still are iterating and have a lot of questions, okay? And it takes a while. It's not like an oil and gas permit, probably here in Texas takes weeks or something. In New Mexico, it can take a year. This kind of permits may take several years, okay? But you have to do all of that before you start into the execution phase. So you're adding a lot of knowledge, and the main thing here, as you were mentioning, is that you have so much data that you don't use it, or sometimes you don't even know where to start. But you also have the risks that you learn after the execution and after finishing a project, okay? So for example, I use a lot of GIS. I go to the national bodies, whatever, I try to browse the internet, I use Drilling Info, I use the Railroad Commission, I use the local government, and some states have a lot of really neat shape files and have their information is very well gathered, okay? But for example, in this case, I needed to plan some wells in Georgia, there's no info. And I tried, even with my ChatGPT, he recommended that I go to some websites, there was nothing there. But the important thing is that, well, I can get some information and I can click on a well, but then the information that's on that well can be from like 1955. So, you know, it's not even digital. It's just a scanned copy of something that tells you something that can allow you to plan a well. So if I go more granular, I have to decide how I'm going to plan a well on a field development in order to optimize the injection, comply with regulations, because you need a boundary between types of well. And there's a lot of factors that you need on a field development that's worth billions of dollars, okay? So you, for example, you do your mobilization, you drill a surface hole, an intermediate hole. In this case, you call it a protection hole, not a production hole, because you're injecting, and then you go for the testing. But when you're testing, you still have not proven the real feasibility or the risk that involves doing the large investment. Okay, so then you go to the physical properties of a reservoir. You go porosity, permeability, you evaluate your injection rate, you evaluate the compatibility of the waste or the injection, if it's CO2 or if it's hydrogen or if it's a particular waste from a site, okay? Then you evaluate the storage capacity and you do your simulations, you do your dynamic model, you do your static model, okay? And you always prove feasibility. But if I had a tool that would integrate softwares, would integrate lessons learned, best practices, that would scrape the web and find information, go to GIS, place it there, it sounds like a lot. But at the end of the day, those are repetitive tasks, and it's more or less of Pareto, you know, like 30% of the 70% or 80-20, whatever. It's really repetitive. You still need to iterate, and you still need to make sure that whatever the outcome is makes sense, okay? So in this road, in order not to get old, I started learning new words. One of them was prompt engineering, okay? And I'm starting to learn how to actually kind of create formulas out of natural language. My main goal is integration. My main goal is to get stuff from the web, public data many times, organize it, and if possible, extract the information so I can plan better wells. And my internal documents are also important to mix them, but those internal documents, as you guys were mentioning, they are kind of confidential, so that's your information, and that's not on ChatGPT. You need a dedicated tool for that. So at the end of the day, there's this writer, his name is Lewis Carroll. He's famous for being a British mathematician, but most famous for writing Alice in Wonderland and Alice Behind the Looking Glass. And there's a scene where Alice grabs the Queen of Hearts' hand, and they start running fast. And Alice asks the Queen, "Hey, but why are we running so fast?" And the Queen says, "Hey, no, we're not running fast. We have to run faster because in this country, you have to run real fast to stay on the same place. And you have to run twice as fast to get somewhere else." And I think that's how I would summarize the new tasks that we need to learn not to get old. Thanks.
Great. Well, that sums up our speakers for this evening. Do you guys have any particular questions for them? Okay. Well, we did have a few that we'll probably would like to share and see if interest. I know some of you guys have some security concerns, questions about it. So Changsu, if you would probably, maybe can you elaborate a little bit more? So oil and gas has been, have some concerns adopting new technology, and how are oil and gas company reacting to AI? What can they do, and what do they can start having conversations on?
Yeah, what was the concern?
About security concerns.
The security concern? Yeah. So as we are working with like financial services, institution and insurance, the industries, and I think oil and gas is also, pretty much the same in terms of those, data, the sensitivity. When we work with like, the e-commerce or tech industry, they are relatively open, don't really concern too much about the data securities. But those in the financial services, insurance, and oil and gas, is absolutely the important for data security. And in terms of those the strong tightness into data and AI, this is kind of the universal questions. So like whatever type of deployment you are using, like the 100% SaaS or the on-premise or the hybrid, the important thing is data is always yours, and any AI model that was being trained by your data is always your model. So whoever vendor that you are going to work with, the first question that you need to check is, okay, data that coming in from our company is stay as ours, and then how the data is being fed into the training the model, and then that model is not going to be shared with any of your competitors. So that kind of question is kind of the de facto standard question that you are working with any type of the AI vendor.
Okay, great. Well, thank you so much, gentlemen, and appreciate for your time and attending us. So if you have any questions, feel free to reach out to us. We have our information. This recording will be available also on your YouTube channels and also will be posted on LinkedIn. Thank you. And if you would like to learn more about our products, please reach. Changsu will be here for a few minutes, and hopefully we'll see you guys on our next forum. Thank you.